Hi everyone, I'm Anmol and I'm going to be explaining my project on retinal condition diagnosis using ocular optical coherence tomography scans. This project was a national winner in the machine learning, that is ML category of the Google India Code to Learn Challenge 2019-20. This category challenged Indian students in grades 11 and 12 to create machine learning applications using Google Cloud's state-of-the-art AutoML Vision, meant for images, or AutoML Natural Language, meant for text. The first step was selecting a project. I was fairly sure that I was going to create an ML application in the healthcare domain, since I'd read about many situations where there was a shortage of medical professionals, especially in developing countries, resulting in long waiting periods for patients and severe inconvenience, particularly for the elderly. Since my 91-year-old grandmother faced this problem when she had gone for her eye checkup, I decided to focus on the shortage of ophthalmologists. Using data from an article published in the British Journal of Ophthalmology 2015, I created a plot in Wolfram Mathematica showing the global distribution of ophthalmologists per million population. As you might have noticed already, most of the countries are blue, showing less than 50 such specialists per million people. Consequently, I resolved to create an AutoML application that would make it easier to diagnose degenerative eye conditions. In this project, due to the availability of a good data set, the following eye conditions were evaluated: choroidal neovascularization, CNV, diabetic macular edema, DME, drusen, and normal. I'd like to take a moment here to explain these conditions. CNV results in the growth of damaging blood vessels in the choroid area beneath the retina. DME is caused due to accumulation of fluid in the macula, one of the most important centers of the eye. Drusen refers to the collection of lipid deposits under the retina. The one thing that's true about all of these conditions is that they're significant causes of vision loss worldwide. In ophthalmology, optical coherence tomography, that is OCT, is a standard non-invasive imaging technique that uses light waves for confirming diagnosis. The images in this dataset are based on OCT. I was now sure that I was going to implement a single label image classification model using AutoML Vision. The dataset I used was retinal OCT images by Paul Mooney on Kaggle. It contains over 84,000 images, each showing one of the aforementioned eye conditions. The next step was to upload a dataset on which AutoML Vision would train the machine learning model. I chose to not upload the raw dataset since it was huge and large datasets require a lot of time for training and getting good results. Moreover, the dataset was not uniform. There were unequal numbers of images for the four classes. Such a dataset might have led to poor results on classes with lower number of images. Cloud AutoML's guides explain this in a great way. Based on their advice, I decided to upload 1000 images for each class. Since selecting these images manually would have been tedious and might not have captured the diversity of images in each class, I resolved to write a small Python code to randomly take 1000 images from each class folder in the downloaded dataset and save them to their respective custom training folders. This is a small caption of my code. And this is how the images were saved. AutoML has a great feature that allows people to upload the training data as a zip folder, containing subfolders for each class. This meant that I could simply zip my programmatically created folders and upload to AutoML. This was how the Images tab in AutoML looked like. Now, the model was trained for 4 compute hours. The results were promising. Using a score threshold of 0.5, the model showed an average precision of 97.2%, a precision of 94.7%, and a recall of 94.47%. For detailed evaluation, I checked the Evaluate tab as well. The values on the diagonal of a confusion matrix represent correct predictions. The high values on this matrix's diagonal prove that the model was doing very well. Now, I also wanted to know which images the model didn't classify correctly. In fact, I found only 3 images where the ground truth differed from the prediction. This is one of them. Note the blurry appearance. I believe that the primary reason for the model making incorrect predictions about the 3 wrong ones was their poor quality. Another cause was the low frequency of these kinds of images in the downloaded raw training data. For further testing, I requested my mother to arrange some OCT scans from her ophthalmologist friends. Consequently, I was able to procure 24 OCT scans of patients from the regions of Punjab, New Delhi, and Puducherry, relating to all 4 conditions of interest. I tested these images on the model, and it was able to classify 23 of them correctly, implying an accuracy of 95.8%, which was incredible. Further improvements can include involving image processing for cleaning blurry images before testing, conducting surveys using Google Forms for improving data and predictions, and training the model for additional conditions and cases as well. In conclusion, Cloud AutoML is an amazing tool for building, training, and testing AI apps. Encouraging results, quick and accurate predictions, and the ease of scalability of this application makes it a compelling solution for retinal condition diagnosis. This would help in ensuring that individuals with eye diseases get correct treatment in a timely manner and, in addition, reduce waiting time. Since early diagnosis and treatment of such diseases is critical, I feel that AI would greatly help in creating an accurate and versatile technique for predicting and treating eye diseases around the world. I would like to thank Mr. Mukesh Kumar, Head of Department Computer Science at Delhi Public School, Arkipuram, New Delhi, for giving me the opportunity to participate and his constant support and encouragement in mentorship. I would also like to thank my parents and Mr. Tyler Bonin for their encouragement and help. Finally, I would also like to express my gratitude to Google Cloud and the other co-organizers of the Google India Code to Learn Challenge 2019-20. Thank you for watching.